Hello, my name is Yusuke Endoh. In this talk, I will show you some weird Ruby programs. So, what is a weird Ruby program? Maybe you have already seen the first example that I show you today. Okay, this is the schedule of the third day of RubyConf, and you are listening to this talk. The first weird Ruby program is in its abstract. So you may be curious of this part. So let's copy and run it. Oops. Apps. The clipboard is disappeared, so I need to. Okay. So save it as t.rb and then execute it. It prints, no, you have to copy the whole text from you don't know to the end. So let's check the abstract again. And so this abstract starts here. You don't know Ruby weird, truly weird Ruby program. So you need to copy from here and to the end here. So let's run it again. Save it at t.rb again, and maybe the last space is last line is not needed, and run it. Do you understand? This program outputs a text. Can you see? So this text is the same as the source code itself. This is source code, and this is the output. Oops. So let's confirm the output is actually the source code. So save the output as file name out, and compare between the original file t.rb and the out. Okay, it says file t.rb and out are identical, so confirmed. So thank you. So the abstract description for this talk is an executable Ruby code that outputs the code itself. It is, isn't it quite weird and interesting? Okay, so return to slide. Oh. Just a minute. Okay. So skip this. And okay, let me briefly introduce myself here. I'm Yusuke Endoh. I'm a full-time Ruby committer working at Stores Inc., as well as the previous talker, Imaizumi-san, Marie Imaizumi, and Koichi Sasada, you know. And Stores is a Japanese company providing software as a service to support small and medium-sized stores. Okay, so I thought my biggest contribution to Ruby was the design and implementation of keyword arguments, I think. And I also proposed single line method definition as an April Fool joke. And Matt picked this single line def in his day one keynote, so this feature might be more important than keyword arguments. Okay, so recently I'm developing a typo tool for type analysis of Ruby code. But today, however, I will talk not as a committer, but as a weird Ruby programmer. And therefore, I will introduce some weird but interesting Ruby programs and run through the techniques used in them. So first, let's recap the structure of the abstract coin for this talk. This code is highlighted. So you may see there are two big string literals. First one is start with single quote and end with single quote. The second one starts %ban and end with ban. So this program contains two big string literals, and here you and don. So these are method calls, don and you. So essentially, in other words, this is the same as you open parent, don open parent, string literal, close parent, close parent. And the two methods are defined here. These definitions is in the capital begin blocks. So evaluated before the method calls itself. And finally, this program emits the program itself. So code that outputs itself is called coin. It is named after a famous philosopher named Willard van Orman Quine. From the previous code, I extracted only the essence of Quine part, and this is that one. And this code, when executed, prints itself. So, oops, this and this are same. And I don't have time to go into its detail, but I will publish these slides, so please take a look later. So, okay. Now, I will show you the winning entries of Trick. Trick is a programming contest for weirdly programs held irregularly at RubyConf, Ruby conference in Japan. Trick is looking for weirdly programs, and the 7-member panel of judges includes me and Matt, and we evaluate and select good, weird, and interesting programs to award. Trick has been held for 4 times so far. Today, I will introduce 4 or 5 of the winning entries, past winning entries. Other works are available on GitHub, so if you are interested, please take a look later. So the first winning entry I will show you today is this one. This is this one, the most global award at Trick 2022. The author is me. In Trick, the judges themselves can submit their own work. In such case, they are evaluated based on the average score of the other judges than the author. Anyway, let's run it. Oops. Where is my cursor? Oops. Okay, so this is the source code, and it's slightly bigger. Okay, and this is the source code, and run it. Oops. Do you understand? The original source code, Africa is here, and the executed result, Africa is here. So it outputs itself, but the globe part rotated 45 degrees. The output is, of course, is executable again. So you can pass it to Ruby again like this. And now it has rotated 90 degrees. Maybe we are here now. So each rotates 50 degrees each. So by after 1, 2, 3, 4, 5, 6, 7, 8 repetitions, it will completely return to the original position. Check it. This is the original source code. Okay, completely same. Okay. Yeah, thank you. So this was a variant of Quine with embedded globe that rotates when executed. And it also has some advanced features such as you can specify the rotation angle default is 45, but you can specify in 1 or 2 or anything. And also it has also damping the internal map, but I omit them today. If you are interested, please try it yourself later. And implementation techniques include ASCII programming and Quine with steps, and also compression of map depth and some math. But today I briefly explain the first two tips. The first one is ASCII programming. It is easier than you may think in Ruby. To make Ruby code on ASCII, the key is %w literal. So you may know where is my cursor. Okay, this is interpreted as this, so two string array. And you can strip this white space by using array join method. So this returns this string. This is not difficult. So this is not so difficult, I think. And now let's put your favorite Ruby code into this idiom and pass it to eval method. So this is condensed, removed the spaces and passed to eval method, and so it outputs high. By exploiting this, you can really format the Ruby code by inserting white spaces like this. This prints hello world when executed. And another key tip is stateful Quine. I don't have time to elaborate on this, but Quine can have the state with just a few modifications. The above is normal Quine, so it prints itself directly. This prints itself directly. And you can make it stateful by adding some code fragments, this and this. And this code, when executed, it outputs almost the same result, but it has n equal 2. And repeatedly executed, the part is incremented. So you can use this number for the stage of the code, such as rotating globe or something. Okay. Next one. This is the best of Fishable Award at Trick 2022. Okay, let's run it. Okay. Okay, so let's run it. Oops. To be. Oh. As you see, 3 fish are swimming. 3 fish is swimming, and the grass is waving. Interestingly, each frame is an executable Ruby program. So I stopped it and copy it. Okay, copied and pass it to Ruby interpreter. Okay, keep a close watch. Execute it. The execution resumes from that frame. So you can. Okay. Okay, so this is also a variant of Quine that shows fishable animation with 960 frames. This is also based on implementation techniques like ASCII code and state requiring. But also it has the 2D graphics of fish and grass, which is very eye-catching. But it is what is interesting, I think, is the use of error correction technology. This illustrates what part of the code has what role. The orange part, this part is the 2D graphics code, but corrupted by fish and grass. And the black part is redundant data for error correction. And the pink part, it is a bit to see, but this is pink. And for error correction code, with code for coin at the beginning and end. And this code, when executed, first extract pink part and run it and perform error correction to recover orange part and the black part like this. Okay, do you understand? So the orange part and the black part are corrupted by species fish and for fish and grass, and the error correction program recovers the code. In other words, this program has a self-repairing feature. Now then, it can extract complete recovered to 2D graphics code, and it performs the fishbowl animation. Okay. I have shown two winning entries of Toric so far. Both were coin or its variants. This is just because I personally love coin. However, Toric is a contest not only for coin programs. Next, I will show some non-coin winning entries of Toric. This is the Best Pangram Award of Toric 2013. This is the first Toric. This is a Ruby pangram. A pangram is a sentence that uses all the letters of the alphabet. This program is coded using all printable ASCII characters one at a time. So this is a Ruby pangram, and when executed, it outputs all printable ASCII characters. Oops. Yeah. So, do you understand? Okay. This program may look simpler than the previous entries, but the restriction of using every letter only once is more interesting than you may think. So, for example, consider a local variable. The same variable name can only be written once. So you can define a variable, but you cannot read it. So this code solves the issue by using a special number variable dot. This special variable contains the line number of the last line red. Since this program is one line, this variable is initialized to 1. This is a good use of this variable. Also, you cannot even write integer freely. This code uses some calculation to create needed integers like this. Yeah. Okay, next. This is the most reserved award at Toric 2018. As you can see, this is just a list of Ruby keywords, but it is executable. Stop. This is the keywords, just keywords, but it is executable. So nothing is produced when it is executed. What is interesting is that no syntax error is produced. the fact that there are no syntax errors in this text is very amazing. And so it got a gold medal, TRIC 2018. And this is also very technical. And for example, it makes very clever use of keywords, such as this begin is not keyword, this is a method name of alias, for example, and this is modifier unless, and blah, blah. So if you are interested, please decipher yourself it. Okay. Okay. The final piece, I'd like to present TRIC 2022's most anti-gravity award. Okay, let's run it. Oops. This is the code, and let's run it. Oops. Okay. It waves the string TRIC 2022. Of course, this is not all. Let's try to remove all spaces from this program. So the output looks crashed to left, I think. So save this as up.rb, up.rb. up.rb behaves differently from the original source code. It crashes the input text upwards. For example, this is a sample text, and applying up.rb to this text. Okay, so every characters are moved to upward as possible. So next, apply up.rb to the original source code. Moment 2.rb. The output looks crashed to the upward. Save this as left.rb. And you may already understand left.rb is also a text manipulation tool, and it moves all characters to the left. Okay. No, no. We have up.rb to crash up and left to crash left. Here's where it is getting interesting. Okay, let's collapse the original source code up and then left. This program, when executed, outputs TRIC 2022 and crash the original source code. Oops. Up to left, and crash to up. This one is executed. Print TRIC 2022 vertically. Do you understand? Thus, this program includes 5 programs: ticker program and up.rb, left.rb, print TRIC 2022 horizontally and vertically. Okay, so I think you need a recap. So this is the ticker program, original program. Thank you. And if it is crashed to left, it behaves like this program behaves upward crashing program. And if the original code is crashed to upward, it behaves like left crashing program. This is left crashing program. And if crashed to up, then left, it prints TRIC 2022. And if crashed to left and then up, it prints TRIC 2022 vertically. Okay. You understand? Okay. I will only introduce the key idea. this is a gimmick of detects left crash. Originally, code 1 is executed because it is in a string interpolation. However, if it is crashed to the left, code 1 is now a part of the string literal because escaping backslash character escapes the string interpolation. And code 2 is now activated because space is removed and it is now string interpolation. Also, detecting upward crash is a similar gimmick. Once you understand the idea, I think it is easier than you might think, isn't it? And it will take a little more effort to complete the program, but the important thing is the idea. Okay, so I have introduced weird Ruby programs, and all of the programs I introduced today, as well as the other winning entries, can be found here, this GitHub, so please take a look later. And what I want to you to remember from this talk is that we are now accepting entries for fixed streak. Thank you. The deadline is February 28th of next year. So there are 3 months, more than 3 months. You may think you can't write such a program. However, Ruby is very flexible and wonderful language. So if you try, you will be surprised what you can do. So please give it a try. We are waiting for your weird and interesting entries. Okay. To conclude this presentation, I created a new client for RubyConf Chicago. I would like to end this talk by running this. Okay, I have recorded the video of the execution, so I play it. This is the source code, and this part represents a piano keyboard, and then execute it. Chicago, Chicago, the capital. This program plays the song Chicago, that other town. It synthesizes the sound by itself while displaying the piano roll and saves the file chicago.wav file, sound file. This video is made by combining the screencast with the generated wave file. So please enjoy. Do you know this song? Okay, great. This song was composed in 1930 or so copyright is only it has no copyright problem. Okay. Yes. Thank you. Yeah, it is now the original program. Okay, that's all. Thank you very much.